Good evening again, everyone. Once again, I am Liam Robleski, your lecturer for the evening, and today is session 4 of the Schulich Ignite Fall 2020 programming program. That was well stated. Anyway, I don't believe we have anything else to say before we get started, so I think we will pretty much just hop right into it. So, as I mentioned, today is session 4, and here's a brief overview of what we will be going over today. We're going to start with a review of some stuff we talked about last week. So we're going to start by talking about if, elif, else structures, which we talked about last week. We're going to do a review of logical expressions, and then we're going to get into this week's new content, and we're going to do some work with lists and with loops. So let's get going. So we're going to start with our review on the if, elif, else statement. So the way these structures go is that the conditions are checked sequentially. So the program you can see on screen checks to see first if mouse y is less than 500, and assuming that the screen is a total of 1000 tall, this would check to see if we're in the top half of the screen, right? Because mouse y would be less than 500 if we're in the top half of the screen. If that's the case, then we fill it with red and go to the next statement outside of our if, elif, else structure. Then, if we didn't do that, we check to see if mouse x is less than 500. So else if mouse x is less than 500, and that means that we are A in the lower half because we weren't in the top half, and B in the left half. So this would be in the lower left half of the screen. And it looks like we got our colors a bit mixed up when we set up this GIF, but what can you do? So if we are in the lower left half of the screen, then we would fill with green. Else, so if neither of those earlier conditions were true, so we're not in the top and we're not in the lower left, then we must be in the lower right, and here we will fill with blue. And regardless, we will draw our circle at mouse x, mouse y with a diameter of 150. So logical expressions, which we talked about last time, are a bit like our arithmetic expressions, where those take in two numbers and give us back a number. But instead of taking in two numbers and giving us a number, they take in two booleans and give us a boolean. So this first example, programming is fun and programming is useful, is true. That uses the logical expression of and. And so programming is fun is true, and programming is useful is true. And so because they're both true, the whole thing is true. However, the second statement, Halloween has candy and Halloween has Easter eggs, is false, because one of those is false. Specifically, Halloween has Easter eggs is false. And then the last statement, Halloween has candy or Halloween has Easter eggs, is true, because Halloween does have one of those. And again, I'm going to note that computers think about or a little bit differently, because when we do or statements, computers have to answer pretty much yes or no. So we say Halloween has candy or Halloween has Easter eggs. The computer says that's true. And if you said Halloween has candy or Halloween has pumpkins, as an example, that would also be true because at least one of those was true. But people would consider it more like one or the other. Computers think about both is also true for or. Here's an example of logical expressions using not and. So we set up some Boolean variables at the top. So we set up the Boolean variable top. We assign that with the Boolean result of mouse y less than 200. And that corresponds to us being in the top half. Then we set up the Boolean variable bottom, and we assign that the value mouse y greater than 200. And so that will be true if we're in the bottom half of the screen. And then we set up the Boolean variable left, and that will be true if mouse x is less than 200, which means that we're in the left half of the screen. And we say if top and left, fill style red, else fill style blue. So we'll fill in with red in the top left and blue everywhere else. Then we check to see if bottom is true and not left. So that's checking to see if the opposite of left is true, i.e. it's checking to see if left is false. So for that condition to be true, we want bottom to be true and left to be false, which means that we're in the bottom right. And so if we're in the bottom right, we fill with a rectangle, so we draw our rectangle. Otherwise, we fill with a circle. And you can see that on screen as well. And so we do have just one exercise here. I think this is intended to just be review, so I would switch over to our coding window and just kind of walk us through that. So let's pop over there. As usual, I have kind of this boilerplate here to get everything working. So import Spark and then reload. And let me also make sure I turn that on. There we go. So what I'm going to do is %ignite. Def setup. Again, just because I'm zoomed in so far, I'm going to make the screen a bit small at 300 by 300. You can make it bigger because you are probably not zoomed in to 300%. Then we will say def draw. So there's our boilerplate. And now because we want to have something that moves over time, we're going to want to have a global variable. So let's set that up. We'll call it ball sub x. And let's start it at halfway in the screen. And because we also want the way the ball moves to change, we need another one to correspond to its movement. So we'll call that ball v for ball velocity. And let's set that to +2. So it's going to start by moving to the right. And what we're going to do is draw our background in black. Then we will draw our ball, and we will say fill circle at ball sub x, and let's put it at 20, and we will say the diameter is 40. And so if I drew this, it would just sit in the center of the screen. So what we're going to do is say, whoops, those of you who are on the ball, so to speak, will have noticed I forgot my global statement. So here, because we want to use ball x and ball v, we need to do global ball x and ball v. So in order to get the ball to move, we say ball x plus equals ball v, and then we're going to check and see if we're past the right side of the screen or past the left side of the screen. So we're going to say if ball x is less than 20, which would mean that it's past the left side of the screen, and we're going to say ball v times equals -1. And so that says if it's negative, multiply it by -1 and make it positive. If it's positive, multiply it by -1, make it negative. Again, we will say elif ball sub x is greater than, I'm going to do 280, and this is so that the ball bounces when its edges touch the edge of the screen. We'll do the same thing. And that should do it. So if we run that, oops, I forgot to set my color. So we'll say fill style of white. There we go. So we can see the ball bounces back and forth across the screen. Mine moves pretty slow compared to the one in the slides, but that's about how it should look. Okay. Now we're going to get into our new content for today. And so we're going to start by talking about lists. So a list is a structure that holds multiple different values. So it's, as it says on the slides, it's handy for holding a lot of whatever. So it allows you to create a whole bunch of similar variables at the same time. That lets us reduce the total number of separate variables that we have to make. So you can see at the top we have a list that we've called students, and it has Henry, Alice, Jack, Alex, and Carrie. And so we can access all of those using the name students, rather than having to have student Henry, student Alice, etc., etc. So the way that we make a list is by using these square brackets, and that tells the computer that we want to make a list, and they can hold any type of data. They can hold numbers, they can hold strings, they can hold booleans, whatever. So if we again switch back to coding, I'm going to stop this. This isn't going to do anything for the moment, but we're going to say random numbers equals 101 minus 2, 303, 44. And then we'll say students equals Henry, Alice, Jack, and Alex. And you can see it runs. It's happy with that. So that's kind of just, I just wanted to show you that is in fact a valid thing to do. So this is useful because we can wrap them, but we still need to be able to access the information we put into the list. And the way we do that is using what's called an index, and that's kind of the position of the item in the list. But lists start at index 0, and kind of one of the more intuitive ways to think about why it starts at index 0 is it's how many numbers do you have to skip over to get to the one you want. So in this case, where we have 101 minus 2, 303, 44, if we want to get 303, we need to skip over 2 values first. We need to skip over 101, then we need to skip over minus 2. So we say my number's 2, and we access that using, again, these square brackets. So if we again come in here, I'm going to get rid of this draw loop just so that it doesn't crowd things up. So we'll say print random numbers at 2. You can see it prints 303 down at the bottom there. And again, that's because it skips over 1, 2, and then it uses whichever one it lands on. So we can also add items to a list that already exists. So as an example, if we have a shopping list, like the one on the screen, where we have eggs, ham, cheese, and onions, but maybe at some point in the future we remember that we needed to add some extra things to it. We can do that by using this append. So if we remember on our way to the store that we also need to get milk and bread, we can use shopping list append milk and shopping list append bread. And that would add those to the end in order. So I'm going to just go back one slide so you can see in order we have eggs, ham, cheese, and onions. That's in the same order that we said in our code. Here we still have eggs, ham, cheese, and onions are the first 4 elements. And then at the end we have milk, and after that we have bread, because we added those in that order of milk, then bread. So it always adds to the end of the list. Another thing we can do is remove items from the list. So if we arrive at the store and we realize we don't need ham and onions, maybe they're not on sale, so we decide that maybe we'll get them next time, we can remove those using shopping list remove. So in this case, if we wanted to remove those two, we would use shopping list remove ham, shopping list remove onions. And we can kind of one of the last sort of things that we want to talk about being able to do with these lists on their own is using len to get the length. So if we had a list of students that looks like Henry, Alice, Jack, and Alex, and then we say amount equals len students, that will give us the number of items in the list. So in this case, that's 4. So let's go demonstrate, but using our shopping list. So if we come in here, we say shopping list equals eggs, ham, cheese, onions. We can print the len of shopping list, or we could set, let's do amount equals len of shopping list, and we will print amount. Then we'll say shopping list append milk and bread, and we'll do the same thing again. So we'll say amount equals len of shopping list and print amount again. So if we run that, we see 303, then 4, then 6. So the first time around, there's 4 items in the list. Then after we add 2 items, there's 6. And we print that out as well. We can also change the values that are already in the list. So you can see here we've created a list numbers, and that contains 2, 5, 6, 8. Then we can change what's stored at index 0 to be 3 instead. So that would change it to be 3, 5, 6, 8. And that looks like numbers at 0 equals 3. So we can use these elements of a list similarly to how we used variables. So numbers equals 75, 150, we can then do circle at numbers 0, numbers at 1, numbers at 2. And that would do the same thing as circle at 75, 150. So that would create a circle at x position 75, y position 100 with a diameter of 50. You can't just do circle at numbers, that won't work. We need to access all of those values individually. So, quick question 1. What will be the diameter of the circle that we draw in setup using the code on the right here? And keep in mind your indices. And we will again give you guys about a minute or so to answer this one. So for clarity, the code that we have is x equals 20, 40, 60, 80 as a list. We say x at 1 is equal to x at 1 plus 10. X at 3 is x at 1 times 2. Then in setup, we draw a circle at 150, 150 with a diameter of x at 3. And once again, we're using the Zoom polls for you guys to answer these. So make sure you put your answer in on there. So you now have about 15 seconds left to put in your answer. So those of you who haven't, make sure to do so. And that is time. So the correct answer is 100. So we can see here that if we have our list x, x at 1 is the element that we have to skip over 1 to get to. So we skip over 20 and we have 40. So we say x at 1 is now equal to x at 1, which is 40, plus 10. So that's 50. So we say x at 1 equals 50. Then we say x at 3 is equal to x at 1 times 2. We just set x of 1 to be equal to 50, so now x of 3 is 100, because 50 times 2 is 100. And so when we draw it overall, we end up with a diameter of 100. So now that we have kind of the basic gist of how to use lists and how to access things, our first exercise for the evening is for you guys to do a bar graph. So we want you to use a list to draw 4 rectangles, all of which grow as you move your mouse around. And you can see the hint on screen there for how you might be able to go about doing that. So to our breakout rooms when we are ready, Animal. Okay, looks like we've got just about everybody back. So I will, excuse me, I'll briefly go over this example and then we will continue onward. So set up our boilerplate to begin with. So def setup, size 300, 300. And draw. So what do we want overall? We want a list of heights. So those are the things that are different on each bar. So if you paid attention to the hint, you would note that what you want is the position of these bars to be a bit different. So we will say bar heights, and we will say I'm going to eyeball these numbers. So we're going to start with about 17, and then we will say, I don't know, 60 and 170 and 230. Let's go with those numbers. Then we will say, we'll draw a background. So let's go again with yellow. So we will say background yellow and fill style of blue. Then we'll say we want to draw a rectangle whose the left side starts at 0x and its height is at bar heights at 0. And its width is going to be mouse x, and its height will be, let's make it, for the sake of visibility on my screen, 15. I'm now actually just going to copy and paste this code 4 times. And on this one, I'm going to change it to be bar heights at 1, bar heights at 2, and bar heights at 3. So if we draw that, we can see that as my mouse moves around on the screen, the bars follow it in the x coordinate. Exactly like we wanted. But you may have noticed that I kind of repeated myself 4 times there. In fact, I literally copied and pasted. So that's going to bring us into our second topic for today, loops. And today we're only going to be going over the basics. We're going to be talking about the most common type of loops in Python, and that is for loops. So loops in general repeat code a certain number of times. For loops are a very specific kind of loop. We'll talk about, I think, while loops on next session. But here's an analogy for loops. So you can think about a dentist. So the dentist starts at the first tooth, checks to see if it's healthy, moves on to the next tooth over and over again until they've checked all of your teeth. This is very much like what loops do. They start at the first value and they move on, they do something with it, then they move on to the next one, etc., until they've run on every value. So in particular, when we use loops with lists, they're very, very useful. So the example on screen will print out every value in shopping list. So we say for item in shopping list, we want to print out that item. And print item is repeated for every value in shopping list. We will again just come into, I'll come onto the platform to demonstrate. So we'll say night. Shopping list is eggs, ham, cheese, and onions. We will say for item, I am aware it's going off the bottom of the screen, by the way. So for item in shopping list, we will print the item. If we run this, we see it goes through and it prints each one in turn. Oops. So, quick question number 2 for this session. What will this piece of code print? So we have numbers equals 2, 3, 5. Start by initializing x to 0. We say for number and numbers, x plus equals number, print x. And again, we'll give you about a minute and a half to answer this. So make sure that you can find your Zoom poll to give an answer on this one. You have about 20 seconds left. Okay. So the correct answer for this one is 10. And you should be able to see that. So the reason for that is we start with numbers. We start with our list numbers, and we start with x being 0. Then for each value, for each number in the numbers list, we say x equals x plus that number. So the first time around, that number is 2. So we say x plus equals 2. So now x is 2. And we say the next time around, number is 3. So we say x plus equals 3. So number is 2 plus 3 is 5. And the last time around, number is 5. So we say x plus equals 5. 5 plus 5 is 10. And so overall, we get x equals 10. So when do you want to use loops? So if we look at the kind of code over on the right side here, you can see that we have, if we wanted to print each number in this list plus 2, without using a loop, it ends up with a lot of kind of wasted code, right? You can see we repeat n equals numbers at whatever and print n plus 2 over and over again. We have to write that many different times. That certainly is interesting. We will look into that, Carter. Sorry. So yeah, this is long and repetitive. So the repeated code that we have can go into a loop. So the variable changing, in this case n, whoop, you all will have to give me just a moment. I hope I still sound okay, but my computer has frozen. My desktop window manager is having issues. But in any case, the variable changing, so setting n to be numbers at whatever index, is different. My computer had issues there. Did that all come through okay, or did I cut out? It was good. Okay. So yeah, the line where we change the variable can be placed into a for loop, as you can see over on the left here. So we say numbers equals 10, 20, 30. Then for n in numbers, print n plus 2. And this does exactly the same thing as the code over on the right side. And I'm going to need to quickly find that window. There we go. So we're going to walk through how this goes. So we can see that we have our list and we have the loop. So we start by saying n is 10, and we print n plus 2. And then we go back to the top. Then n is 20, and we print n plus 2 and go back to the top. Then n is 30, and we print n plus 2, and there's no more numbers to go over, so we're done looping, and we leave. So using a list and a for loop, we would like you guys to now draw 5 circles falling down the screen at the same time, and that is our second exercise for today. And you can think about how using a loop helps us draw those circles in much less code and much faster overall. And back to breakout rooms when we are ready. Okay, looks like we've just about got everybody back. So once again, I'm going to quickly go over this example, and then we will proceed onwards. So, as usual, do the boilerplate, and then we'll say draw. So you may have noticed that pretty much the only thing changing here is the Y position. So you could do this with proper gravity so that they fell faster as they started falling. I'm not going to do that. I'm just going to make them all move downwards at a pretty constant speed. So we're going to say that the Y position, we're going to start that at, let's say, 15. And then in draw, we're going to set up a list of ball positions. So we're going to say ball positions. We're going to make a list, and we will do, let's say, 40, and if we do then 100, 160, 220, and 280, that'll work. What we're going to do now is say for ball X in ball positions, colon, we're going to draw a circle at ball X and the current Y position, and with a diameter of 30. I did forget to put in a background, so we will add that in real quick here. Let's make the background green. And then the last thing we need to do is update the Y position. So we'll say Y position plus equals 1. Whoops. I forgot to do my global Y position. Global Y position. So you can see we get these balls moving down the screen all at the same time but spaced across the screen in much less code than we had before. And you can see that this could potentially be much more useful in other circumstances as well. As an example, we can mix for loops and if statements to make these balls change as we go across. So on the left you can see we have a for loop, so for x in x positions. If x is greater than 150, so if the center of the ball is more than 150 across, then we'll fill with some color. Elif x is exactly equal to 150, we'll fill with a different color. Else, fill with a third color. So what this will do is balls on the left side of the screen will fill with one color. In this case, it's a sort of magenta. Balls that are exactly centered on the screen will fill with orange, and balls that are on the right side of the screen are going to fill with a light blue. And the way that that works, if we step through it, is we can think of it as x position. We have our x position list up at the top. So the first time around, x is x position at 0, so it's 30. We enter in and we check, is it greater than 150? No. Is it equal to 150? No. So then we fill with our magenta and we draw our circle. Then we go back to the top of the loop and we use the next value, in this case x position at 1, and that is 90. Is 90 greater than 150? Nope. Is it equal to 150? Nope. So then we fill with magenta and draw a circle again. Go back to the top. Now we use x position at 2, which is 150. So we check to see, is 150 greater than 150? Nope. Is it equal to 150? Yes, it is. So we fill in orange, then draw our circle. We do our next one. X is x position at 3, which is 210. Is 210 greater than 150? Yes, it is. So we fill in a light bluish. And draw our circle, and then go back to the top and use our last value, 270. Is 270 greater than 150? Yes, it is. So again, we fill in blue. And so you can see using for loops and if statements, we can end up with these things that change horizontally, but in kind of classes, which is another really useful way of using them. So we have no more content for you today, so we're going to go into the exercises for you guys to work on. So the Bug Busters exercise, we have the first one is draw a snowman, and we would like you to use a for loop for that. Excuse me. The second exercise is to draw an upside down pyramid, as you can see there. And then the Pythonic lava exercises, a ball of yarn. So you can see that as we go down, the ball shrinks and we store all of the coordinates where it touched the bottom. And then we also have a brick breaker example over on the right. So those are the exercises for you guys for this week. And we are going to go into breakout rooms once again so you guys can have some time to ask any final questions you have about anything we've talked about and work on these. So, Emma, once again when you are ready. Okay, looks like we've got just about everybody back who's coming back. So I would like to thank you on behalf of everyone here at the Schulich Ignite team for joining us once again for today's session. That's all we have for you today. I hope you all learned something. I hope you had fun. And we will see you next week. Have a great evening and a great rest of your week. Cheers, all.